Why aren't you working? It's lit up. Okay, well, we're just going to hit the spacebar. Alrighty then. Maybe we won't even hit the spacebar. There we go. All right, so getting started with Network Plus. So in this module, or the 2.1 section, we're mostly going to be talking about the bigger picture of network topologies. So what I mean by that is knowing the difference between like a wide area network, a metropolitan area network, a LAN, and then we'll at some point get into VLANs. So these are bigger picture. So inside of those is where we're going to see different topologies. Okay, so the topologies that we just talked about on the board, the star, ring, bus, mesh, all of those exist within these different type of networks.
So it's like a classification of network,
And then your actual topology. Yep, absolutely. We're going to talk, obviously, a little bit about IP addresses. Hopefully you guys remember some of that stuff from last year. We're going to talk about subnetting. Last year we talked a little bit about subnetting, but we didn't really do any like subnetting problems. It was more of understanding that subnets divided networks. This year we're going to have to go through and learn how to subnet out class A, B, and C networks, okay? I will warn you with networking, a lot of this stuff is theory, so it's not as hands-on, but there are simulations and labs throughout to hopefully pull the kinesthetic learners into what we're doing. But that doesn't mean that we can't set up a lab, or if you're like, hey, let's see how this works, let's apply the subnets to like a Cisco interface, we have no problem doing that, okay? So our goal is to get through the networking stuff and then do a little bit of Linux, and the faster we do that, the more time we have on the ethical hacking portion of the course and more of the Security Plus type of content. I know a lot of you guys put down Security Plus as one of the certifications that you wanted to get to, so getting through the networking stuff is just going to help you understand the Security Plus content. Because if I came in and I was like, hey, you have to set up a firewall that blocks this VLAN from accessing that VLAN, if you don't even know the common language or how to even conceptualize what that looks like, then you're not going to understand some of those concepts. Not saying that it can't be done, but it's going to be harder. So we're going to establish kind of a good solid base in networking, and then we're going to move on to, like I said, just enough Linux to get you started. That being said, you'll be able to go for your Linux Plus certification. You'll just have to do a little bit more studying on your own, because I want to get to the fun ethical hacking stuff as much as possible. Now, as we're going through the networking things, I might inject some like Try Hack Me Labs or like some virtual machines for you guys to download to learn about the different protocols by attacking them. So if we're talking about FTP, I'll have a vulnerable machine set up for you guys to take advantage of some of those insecurities in FTP. Does that make sense? So we'll still be peppering in cybersecurity throughout, but really the goal of this first semester is to get up to speed on networking. This should have happened at the end of last year, but with everything last year, we just didn't have time. So we're going to try to get through as much of it as possible. So some key terms that you should know, obviously, IP address, subnet address, those things are going to go hand in hand, okay? Anybody remember, what is a subnet address? What does it look like? What are some of the numbers that you can expect to see in a subnet? Yeah, so 0 and 255, those are kind of the on and off bits for whether a network is, whether a host is in a certain network, okay?
Wouldn't that be like how it accepts, like how much it accepts? For example, if you have 255, 255, 255, 254, it only allow one device.
Kind of. Your subnet does determine the amount of hosts that can be on that network, but it doesn't necessarily limit the amount of like bandwidth or anything like that. It's just how many hosts versus networks.
One device, though, due to the fact of it only having one available.
No. So that specific address, no, because you have, and we'll learn about this, but you have to have your broadcast address and your gateway address to be able to communicate. So you actually the smallest that you could go would be a network that has 3 addresses in it. And we'll get into that as we kind of take a deeper dive. But those are some things that just over time, that it's just repetition of understanding like gateway, subnet mask. Those are the things that you need to have connectivity on a network. Local area network versus a metropolitan area network versus a wide area network. Those are the 3 things that you're going to need to know for the network plus and kind of what purpose they serve. Then a big part of networking now is, especially now with a lot of the cloud software, is software-defined networking or software-defined wide area network, where we're actually using our, instead of just hardware, putting like a hardware device in, like a router, in order to route between networks, we're actually doing more and more of that with software and virtualization. Some other protocols like multi-point generic routing encapsulation, similar to like a VPN, but we'll dig into that a little bit more, and intranet versus an extranet. If you were to just, and I've told you guys this before when it comes to some of this stuff in networking and technology, break down these words. When you think of something like intra, what does that sound like? Not necessarily intranet, but intra. What? Internal, right? That intra, so it's an interpersonal skill, it's an internal thing. Extranet is external, okay? So even if you don't necessarily know the difference between them, just looking at some of these words, you can kind of draw a conclusion of the bigger picture of what it does. We talked about topology, and then we'll get into like what a terminator is, which is not the movie character, not, what was his name? Arnold Schwarzenegger. It's an actual device that stops the networking, stops the network from continuing on. You can, sure. Some key definitions for you. We just kind of talked about those already. But again, if you need to review or put in your notes, make flashcards, these are definitely things that I would put in there if you're preparing for the Network Plus exam. The Network Plus exam is great to have, especially if you're going into more of the IT side, because it shows that you understand kind of how the bits and bytes move around the network. So again, flashcards are something that I would definitely create from the definition. So why do we need networks? Let's start with that question. What's the point of having a network? So you can have internet, okay? The internet is a network, right? But what is having internet, what is that giving you access to? Yeah, communication between you, other servers, or if it's like a chat service, it's different services, right? So there's 2 different things that we need to kind of take inventory of when we're designing networks, when we're troubleshooting networks, and that is our network components. So what is living kind of on the network or devices that people need access to, and then what are the nodes or the hosts that are going to connect to those devices. So what are some examples of some networking components using our context clues on the screen? Top one. I think I have a little green pointer thing. Oh, it doesn't work on the screen. Oh. Did you say, someone said it? Printer would be one. Server, someone said websites, accessing websites. A router is a device that kind of helps, it is a network component, but it helps that communication happen, okay? Storage, it might be a network attached storage, or even, yep, that would be a network component that gets you kind of outside the network. Absolutely.
A modem, basically, the router is just the original signal.
The modem's the signal that connects back.
That is actually spreading the signal.
Other way around.
Like for example, if you just had a router, you could only connect one device and then be able to go.
Right idea, wrong devices. So your modem is what dials to your internet service provider. Your router then is what allows multiple devices to connect, and it'll connect via wired, wireless, fiber, and then sends everything out through that modem. So the main things that the main ways that we connect devices these days are twisted pair. You guys want to make cables again? No. Was that so fun? No. I actually watched this summer. I watched a team of guys run networking cable, and they really loved doing it. Good for them. But I was like, they're like, yeah, we just get to, get connectivity into places that people don't think it's possible. I'm like, that sounds like a great mission statement. Not something I want to do. I'm just not passionate about it. It's not my jam.
I have a good heart behind it.
Sure, absolutely.
Not something I you hate what I do.
No.
Some people think it's fun going up in like booms and bunching telephone poles.
Yeah.
To each their own. Like,
Yeah.
if that's what you wanna do, it's what you
And
wanna
I don't feel like I got that vibe from any of you last year
do. No.
as a possible career.
Well, no, listen, I like helping people, but I would not go through that much pain again.
That's
Yeah.
also because I've done it like 150 times.
And the running the cable is different than the terminating of the cable too. I feel like
No.
having to put Cat 5 or Cat 6 ends on all of them.
It's different because if you have to move a ceiling tile every time and
Yes.
move a ladder 10 feet and then do it again and do it again, then it's
Mhm.
like repetitive.
Have you seen the pneumatic? Did we pull up the video with like the pneumatic cable shooters?
No.
They have like a crossbow that you can get to shoot cable like
I
across.
don't think the school would allow.
And it
that.
like
What's
they have
the
they have
way?
like magnetic ends, they have like plunger ends. So you literally like aim for the other side of the building and then it's pneumatic and it's like launches it all the way across. Yeah.
I feel like the
Pretty
school
cool.
would allow that just
I wonder if we can order
to
one. I feel like we should order one. I wonder if we'll get that approved. Probably not.
Get that approved.
The school would be like, why do you have a crossbow?
We'll let them use it. We need that for the new building. Definitely need that.
Just tell them what the actual purpose behind it
Yeah.
is.
So the main ways that we connect things: twisted pair, fiber optic, Wi-Fi. Some of this should be review over the ITF Plus and the A Plus stuff. The network interface is going to be wherever the cable plugs into. And what I mean by that is it doesn't necessarily have to be a router, a switch. It can be on the computer. So there's a network interface card, right? On a switch, they all have individual network interfaces, your routers, your modems. That's what your network interface is. What's that?
Like, you know, the LAN, not the LAN, what's it called?
Hmm?
Like, you know, the phone cables, how you plug those in, those are technically a network, aren't they?
So that's going to connect you back to the interface.
DSL.
Oh, yeah. So like a DSL modem, for example. But the network interface, so for example, we ran all of the cables last year over to the patch panel and then the patch panel to the switch. The network interfaces in that case would be the computer that it plugs into and then the switch port. The actual patch panel is just kind of an intermediary device.
Now, I didn't
That makes
call
sense.
my grandma weird because, like, she had this DSL for, like, years on end.
Mhm.
It ran, like, really slow.
Was it Nova?
Like, it was
Nova DSL?
Zexal, or whatever it was called.
Mm.
It was the Nova.
That's the modem.
Phone company.
Yeah.
But I'm like, okay, grandma, I'm sorry, we're gonna have to get rid of this. She's like, why? It's like, if I ever have to do something on the internet for my class, it's not gonna work on this.
It is getting better. Nova DSL should be getting gigabit upgrades, so we're going to be pushing DSL,
We just basically got rid of it and got Armstrong instead.
just like you and pretty much all the other customers. Network protocols. So network protocols are kind of a list of how data travels across the network. Okay, so at the end of the day, it's all zeros and ones, but how those zeros and ones are actually formatted determine what protocol is being used. So think of it like our language. So you speak English, I speak English. Our protocol that we can communicate in is English. If you only spoke Spanish and I only spoke English, we're not going to be able to communicate, right?
So it's kind of like how computers communicate with binary, for example.
Yeah, but on top of it's going to be binary, but how it's formatted is the language in which they speak.
Like hexadecimal.
Nope, it's always going to be binary. Yep, so those zeros and ones, but a layer above that is the actual network protocol. So like FTP, for example.
Java.
Nope, it's going to be like your FTP, it's going to be your,
Oh, like the actual network.
yeah, so FTP is going to fall under a certain protocol of how data goes back and forth.
It's like file transfer protocol.
Yep. So like we talked about before, what are networks for? The biggest thing is to be able to share peripherals, because if we didn't have a network, this is what our networks would look like, right? Everybody would have their own printer connected, and we would have to manage those. But then with our network, we can actually have a single shared device, maybe a bigger device, a lower cost device that everybody can have access to, and it can have more features. And we could also use things like paper-cut in the case of a printer in order to reduce the amount of people. Like we can limit, hey, you can only print 10 pages a day or 10 pages at a time or whatever that is. It helps us manage that device a little bit better. Yeah.
Why don't we have a limit to how much we can print here?
We have the ability to with paper-cut, but they try not to limit.
Try not to do it in case you actually have to print out like
Yeah.
a big essay But they don't want you abusing it. If they see you abusing it, they will definitely.
No, they definitely won't limit you, because I've seen some people print,
Well, I
something
mean,
like that.
listen,
Yeah.
but if they actually had a reason behind it, like it was like something they were doing in class and wanted a paper copy.
And honestly, so the cost of printing is, especially here, everybody having Chromebooks, there's very little that needs to be printed. The print costs are so low. The time that it would take to manage and for those times that you'd have larger stuff, it's just not, the juice isn't worth the
You also,
squeeze,
like,
especially because there's only one person. So
Makes sense.
that's probably why it's not limited as much.
And plus, it's like a massive copy of that 4 paper trays.
So besides printers, you can do the same thing for storage. So back in the day, everything used to be on shares, like probably even like when you guys were first in elementary school, they had like student shares or teacher shares that you guys could access to. Now that's moved more to the cloud. But it's still, networks are still sharing them. It's just using the cloud as far as the network.
So
Okay.
More like Google Drive and stuff.
So some of the benefits of network sharing, or I'm sorry, some of the benefits of actually having a network are files being shared back and forth, being able to send emails, communication, even phone calls with everything from like Snap phone calls to Discord phone calls, so like voice over IP. Even phone, like our phone calls here when they leave the school, they travel through the internet before they're handed off to the actual POTS lines or the plain old telephone system line, if that makes sense. So-
I don't think social media is really an advantage in some cases.
No, it is. It definitely is. Networking is what allows that to happen. So
Yeah, but
it
I'm
is
saying
a
just
benefit
because, like,
of
stuff
that.
happens, the external sources, they can't help it.
So when we look at actual network types, there are a couple different ways. So you guys are probably used to this one that we looked at before, where you have computers that are connected to a network and they access a resource, okay? But you also have the ability to do peer-to-peer networks, okay? So that's where computers can share their information that they have, but they can also receive information from other devices, okay? So from peer to peer, so they can provide and consume. So with that, we can have a computer that has a printer attached to it. We can have another one that might have a really large hard drive. They can actually share the resources they have. Notice where they're connected in this diagram, right? They're connected to the computer first, then the computer is connected to the network. That is a peer-to-peer network where you're talking to other nodes on the machine or other hosts in order to get access to those resources. When everything is shared from a single when everything's on a single device, that's going to be more of a client server type of topology or type of network. Okay. Yeah, question.
So, the, client server, because it's split into the different areas.
Yeah, because these different nodes are sharing it out.
Yeah,
So
they're
you don't
not-
have a defined, all these clients go to that computer. They're all kind of servers.
We also said they can also access like the internet program.
Yeah.
Where you can't access the internet on a client server because the client server is like for example, you can't like you can access files through other people
Mhm.
on a client server. However, you can't like access like the internet on those computers.
So in a client server in that type of network, the server is sharing everything out. Doesn't really have anything to do with internet per se.
Well, I'm just
We're
saying, like,
just talking
you can't,
about
like, use
resources.
Google Chrome browsing, but
Yeah,
oh, you could on that?
on a server.
No, like on a client server.
Let's talk about client server and then re-ask that question. I'll try to clarify it when we actually look at the topology, because I don't think I understand what you're trying to understand. So when we look at client server, we'll look at it again, okay? So in this case of a peer-to-peer network, you see one computer has storage, the other one has a printer, and they share it. Some of the advantages, especially in like small to medium businesses, you don't have the cost outlay for a server. You don't have to have a certain level of expertise to set up a server to, download those licenses. It can be cost prohibitive, right? And there's also a level of, you can go buy a consumer computer, a consumer printer, and hit the share button, and now you can instantly share or print things from your mobile device, okay? And in all of these examples, they don't necessarily have to be computers on a peer-to-peer network, okay? A mobile device or a tablet can also be that peer-to-peer device. Some of the disadvantages, this is really hard to scale, right? If this was a peer-to-peer network and we lost power to half of the building, well, what happens to our printer, right? If we're over here and the power dies in this part of the building, we lose access to that printer, right? It's not going to scale up. We all of a sudden get 30 new employees. Now they're all trying to go to this printer and everything's going through this consumer level computer, then you're not going to have good throughput. It's going to be a really bad client experience. Also, it's very insecure. Like you're opening up the ability for other users to connect to your machine, so you're just making it more vulnerable. Okay. Moving on to client server. So here we have our server kind of at the top, right? Oh, I'm saying that when you can't actually see. So we have our server at the top here. We have our printer that's shared. We have a website that we built, and then we have storage that is also accessible to this server. From there, we connect to our network device, whether that's in this case, it looks like a wireless router, and then these devices can all access these different resources, okay? So if this computer goes down, we're still gonna have access to all those resources. Now, yes, if the server goes down, then we lose everything, but that's when we look at different scalable options. So if we have 30 new employees that show up, we can have another server that we can add on and do some load balancing. So that way, if one server goes down, we have some redundancy there, okay?
So I guess what I was asking is like if you disconnect the computer from like that server, it just won't have access like the internet.
Yeah, so this server could provide other resources, which is like DHCP and DNS. That's what you need to access the internet. But if this wireless router is doing those services or providing those services, even if this goes down, it's still going to have access to the internet.
Okay.
Yep. Moving right on, some of the reasons that we like the client server, obviously it's very scalable. It's easier to support in the fact that you don't have, you're more set up for success with a server operating system compared to a client operating system that you're trying to do server things. Does that make sense? Like you guys trying to learn Linux on a Chromebook, like it's just not a great,
Well, unless you actually enable a Linux option.
correct, but that's what I'm saying, on your Chromebook specifically, it doesn't work, right? You're trying to use something that it's not meant to be used for. So in that case, having a server operating system is going to have more features, especially when it comes to like security and ease of access and ease of setup, and also other things like data protection with like RAIDs and backups and stuff like that. Some of the disadvantages, you have to have some advanced kind of ahead of time. So for example, at ACA, the school that I work at, we had to, put our order in 6 months ago to get server set up. We had to do some planning on when we were going to implement it because we have to take part of the network down. So it takes some pre-planning. If I was just adding on a new printer on a peer-to-peer network, then I wouldn't have to I would just literally buy the printer, connect it, and be good to go. Also expensive, so your entry-level server, you're looking at spending like $4 to $5 grand, and that's on a pretty low-end type of server, compared to just a $500 Windows machine that we get from Best Buy. Okay. Let's talk about IP addressing. Do you guys want to take a break really quick and then come back to it, or do you want to push through? Push through. All right. So network addresses. So network addresses are obviously, from the diagram, they're very similar to house addresses, right? So my address is 941 US Highway 224. So that tells you that, what's that?
No.
It's very public. You can look up my name and go to the auditor's website and see that. So in this case, we can see 732, 739, 744, okay? So with that, we can then know if when we're sending mail or sending communication, where we're going to be sending that information. Networks are the exact same way, okay? So we have PC1, PC2, PC3, or we have the 192.168 network. So this is like the road that they're on, the actual network. The actual number is the house number. So the school's address is like, 1065 State Route 60, or 1783 State Route 60. So in this case, the 1 would be the 1783. The 192.168.1 would be the US Route 60, okay? So in our example here, we have our house number. That's very similar. That's the same example I just gave. So if we have two different roads, what's that?
So basically what you're saying is that like the 192.168 is like the street you're on.
Yep.
And the house number is like what the computer is.
Correct. Yep, absolutely. And if you have two different networks, so where two roads cross, I just had like a Robert Frost moment to take the road less traveled. But if you have two roads that are that cross, that's like your different networks. Okay, so the 10 dot network and the 192.168 network. So in Nova, we have 224 that goes one way and 511 that goes another. So on 511, that would be like the 10 dot network, whereas the 192 would be like our 224 network. Okay, so those different roads or those different networks are called subnetworks. Okay, they're broken up into smaller subsections for security reasons, for performance reasons. I mean, there's a lot of reasons to subnet out a network, but for now, just kind of entry level, just know that a subnet separates a network.
So wait, like the student, the guest, the
Yep,
staff.
they're all on different subnets or different VLANs in that case. So that way, this computer isn't like our network you don't have access to because we have to do certain things like SEPA and COPA compliance, and we have to make sure that your network that the students have access to is blocking things that the Fed says that we have to block. Okay,
Like video games.
not necessarily the video games as much as it is things that would be harmful to
To the
children under the age of 18. Yep. So that's why we have to block that. The games is just more of a local policy that the administration here has said we don't want kids to have access to that, but that's not necessarily the federal guidelines. Local area network, so that's like what we have here at the school. All these individual rooms are all connected to a local area network. And there are multiple LANs here. So the security and graphics network is together. And then the rest of like general population is on another network. So we're kind of segmented off. We have our own firewall. We have our own kind of control over what we do in here. Whereas everybody else is on one totally separate LAN. So what's the difference between a MAN and a WAN? A metropolitan area network and a wide area network, yeah.
How big it is?
Okay,
So like, man is city.
Yep.
WAN is like way bigger than a city.
yeah, so that would connect multiple cities together, like Ashland to Mansfield. Ashland would have a MAN, and Mansfield would be a MAN, and the connection that they have in between them would be our WAN connection, our wide area network connection, okay? Pretty easy, pretty self-explanatory. Any questions on that? Makes sense? All right.
Like state-funded type of infrastructure, or is that just like the internet service is paying for it themselves?
So we can definitely take this side road. As far as like funding and networks and how schools get internet, we go through a process called E-rate.
Please pardon this interruption. At this time, with the following students, please report to the group room.
All right, so let's talk a little bit about no. We were going down the rabbit hole of funding. So if you look at your cell phone bill, you'll have a universal services access charge, where like a penny or two will come out of your bill. That goes into a huge fund for schools and libraries to provide internet connectivity. So it helps to augment the price of what access you have. Now, part of that money, as of a couple years ago, it used to be into just like two categories where you could use that money for hardware and software, but and it was based on your free and reduced, kind of your poverty levels. That's which schools kind of got the most resources. That's what they based it off of. So every year we actually put out to bid our internet service, our wireless service, and various other things in order to, it has to be in an open bidding, because the money's coming from the public, it has to go out to public bid. And then vendors will put in their E-rate, what their bid is, and then the district has to choose based on like and I can show you an example of mine that I do, based on various criteria. It doesn't have to be price, but price has to be weighted the heaviest in order to choose what vendor they go through. So that's where that funding comes from.
So it's like a reverse option, you're saying? Where like, they'll say, I can do it for this much, and another company will say, I'll do it for less, and then another company.
Yeah, you don't necessarily know what anybody else is like bidding necessarily. They just send whoever the E-rate contact is, they'll send all the bids by a certain date. And then it's like you have like 28 days that it has to be open for, and then you can choose what vendor you go with. And then there's extra funding if you connect through, like we connect through TCCSA. So there's extra, it used to be like $2,500 that you get for going directly through an A site. So you get a little bit of extra money that way too. And that's per building. So in Huron, I had 4 buildings, so we got like 10 grand just for that. So this is kind of your traditional network that you would have set up. So you have your PCs, and what do you think that big red thing in the center there is?
Like a barrier kind of that like filters it all.
That's the firewall.
That is the firewall, exactly.
Because it's red.
That's just like our firewall, our very
A very protected file.
yeah, absolutely. So we have our firewall, and then we connect to the ISP, and then it goes out to the network. Okay, so when different attacks come in, that's where we are blocking at the firewall level. So at the state, we have, they used to be called the state iron ports. That was the solution that they used. And then at TCCSA, there's firewalls. And then the school district has firewall as well. A lot of school districts don't manage their own. I know Ashland has their own. We have our own. But other schools, it wasn't really common practice to manage your own firewall. You would go through like TCCSA or whoever your A site was. So that kind of stops outside attacks from coming in, but also keeps, it gives us kind of more localized control over VPNs and stuff like that that would be used to kind of circumvent the network, okay? Another thing to just be aware of is this term of a demarcation zone, okay? So your demarc is where you hand off service from the telco, I'll call it, or the internet service provider to your local network. So in this case of the presentation, our demarcation point would be right here, because from this point forward or backwards, it's our network, and then from this point this way is their network. So this is our demarcation point, okay? This is our firewall here, and then this area that we have that's on the outside of our firewall is our DMZ, or our demilitarized zone. And what that means is it's out there in the open, okay? Because we might have clients that are accessing through a VPN. We don't want to necessarily have to get them on this side of the network. There's no need for them if they just need services here. So what that does is it provides us a place to provide services to that outside world and kind of increase our security on our local network, okay? I think we all know how firewalls work. With this case, this is our intranet, so everything on this side of our firewall, that's what kind of falls under that intranet. So we have our server here, we have our different clients, and then we have our switching device, whether it's a switcher or router, whatever it is.
Within the firewall.
Correct, that's our intranet. Now, an extranet is where we might have a St. Louis office and a Cleveland office, and they connect to resources on the other side of the internet, or they go through that wide area connection in order to access them. That would be our extranet.
Two areas connecting to the same connection.
They're using the internet to be able to access resources. So like us and the building next door, we ran fiber in between, but if we didn't run that fiber, we would have to go up to the internet first and then come down here. That would kind of be our extranet, if you will, because it's using the internet as that intermediary device. So in summary, we talked about a few different things today, mostly about the kind of the basics of networking, kind of creating our solid base before we move on. Tomorrow when you guys get in, we'll go through and probably pick a different game. We don't capture the flag, so we'll probably find a different one. I don't believe there are any labs or simulations. I'll have to double check for this one, but review the information. We'll double check and kind of go over everything Tomorrow, do another pass of the content, and then kind of keep pushing through the module. Any questions for today?